Good day all, this is Professor Friday from Macomb Community College coming at you on this gorgeous day out, this Good Friday that is taking place. So what I have for you today is we got a little bit of Newton's method going on. So the problem in question is we are going to be using an initial value of x equals 1. We're supposed to find the third value for the Newton's method approximation of the x-intercept of the function f of x equals x cubed plus 2x minus 4. So, we'll make a little note on here that says that this is Newton's method. Okay, so first thing I'm going to ask you to do is recall the formula that we derived for Newton's method. To find new values of x, we start with the initial guess for x, and we subtract the value of the original function divided by the value of the derivative at that point. This is what takes us a little bit closer to the x-intercept for Newton's method. Now, with that in mind, what we have is an initial guess of x equals 1. We're going to be using the function f of x equals x cubed plus 2x minus 4. We'll also need the derivative of this function. Derivative of this function is going to be straightforward power rule. X cubed gives us 3, x squared. The plus 2x becomes plus 2, and minus 4 is a constant, so that goes away. So from here, if we want to get a couple of subsequent values, then we can set up the expression x2, that's the next value of x that we're going to calculate. This is equal to x1 minus f of x1 divided by f prime of x1. Now that we have both the original function and the derivative, heading back up top to remind ourselves, we're going to start with a value of x equals 1. So that's what we're going to plug into both the original function and the derivative. This is going to be 1 minus f of 1 would be equal to, let's see, 1 cubed plus 2 times 1 minus 4 all over 3 times 1 squared plus 2. Now normally what you would do at this point is turn to the graphing calculator and say, hey graphing calculator, simplify that up a little bit for me. However, I was recklessly irresponsible this break and left my graphing calculator in my office, so I'm going to be a little hardcore about this and try to do it by hand. That's 1 plus 2 minus 4, that's minus 1 all over 5. So we've got 1 minus negative 1/5. We can call that 5/5 plus 1/5, that's 6/5. 6/5 is also equal to 1.2. This is one of these rare situations where I'm going to say decimals are actually preferred over fractions because we use Newton's method to approximate zeros anyway, so we might as well just stick with the approximation. So, to get the next value of x sub 3, we're going to use the Newton's method formula, what we have up here in red, but this time we're using an index of I equals 2 to give us x sub 3. So to get x sub 3, we're going to start with the second value for x minus the value of the original function evaluated at x2 over the value of the derivative evaluated at x2. This one might be a little more complicated without a graphing calculator, but whatever. I'm hardcore, I can take it. 1.2 cubed plus 2 times 1.2 minus 4 all over the value of the derivative evaluated at 1.2. Alright, so again, normally this is the point where I would say toss that whole thing into the graphing calculator, see what it gives you. We're going to try, probably unsuccessfully, to figure out what this value is by hand. 1.2 cubed is 1.728. 2 times 1.2, that's 2.4 minus 4, all over 3 times 1.2 squared, that's 4.32 plus 2. And we'll take this all the way down to the bottom. Let's see, this will be minus 1.6. We'll call this 0.128 all over 6.32. Well, I'm very proud of myself for making it that far by hand, but unfortunately, it's going to be up to you, the viewer, to figure out what that value is actually equal to. Again, I don't have a graphing calculator here today, so that's my bad. Whatever you get for this decimal approximation, and directions for the problem say you can round your answer to 4 decimal places, so whatever you get there, that'll be your answer to the problem. I will see you all again soon.